Okay. Well, and we start from the very beginning. We start to consider C language, and just a few words about history of C language. C language was developed by two employers of the Bell Laboratories company, Dennis Ritchie and Ken Thompson. And the basis of the C language were the language B and the language BCPL. And the C language was elaborated as a tool for practical work of programmers. And Ritchie and Thompson created C language during the work on the operating system Linux. And the main goal of the authors was creation of convenient and useful language, because there are other programming languages, of course, on that time, not on current time, but that time when the C language were developed. These languages took into account these requirements, not always. That time there are some languages like Pascal, Basic, Fortran, and Pascal was oriented at theoretical completeness of constructions. The language Basic was oriented at easiness of learning by beginners. Fortran was oriented for scientific computing, and so on. And the C language was created as a good tool for programmers. Of course, you can read about history of the C language in details using any source in internet. For example, you can open the page in Wikipedia and type C programming language, and you may read about the history of C language in more details. It's written here that the language B was the previous language before C, and the one of the author is Dennis Ritchie. Here you may see his photo, and so on. Well, it's not the main goal of the lesson, the history of C language. You can read it in any source, for example, in Wikipedia. Well, and let's consider the main features. The main features of C language. First of all, C is a contemporary language. It means that it includes the control construction which are recommended in theoretical and applied programming. Its structure is oriented at applying such programming technologies as downgoing design, structured programming, step-by-step development. And if we will talk about C++, of course, in C++, the main programming technology is object-oriented programming. Next feature, the second feature is that C is an efficient language. Its structure allows to use the resources of modern computers in the best way. And programs written in C are usually compact and fast in comparison with other languages. Well, we consider the top, the most used languages. The table with the most used languages in this lesson, and you see that now such languages as Java and Python are very popular, but program written in C and the same program written in Python, if we compare the time of execution, program written in C will be faster in general. Well, sorry. Okay. The next feature of C language, that C is a portable language. It means that the program written in C for one operating system or computational system may be transferred to another system just with the small changes or with no changes at all. It means that, for example, I use Microsoft Windows and some other person used Linux, some other person used macOS, but I can write the program in C, in Windows, and this program, maybe with some minor changes, can be compiled and executed under Linux or under macOS. And C compilers are realized on the most of modern computational systems, from personal computers to supercomputers. By the way, in our university, we have a supercomputer. This supercomputer is in the list of the most powerful computers in Russia. Of course, not all over the world, but in Russia. And we use C when we write the programs for supercomputer. Next feature, that C is a powerful and flexible language. For example, the most part of the operating system Unix or Linux was written in C. And now the language is used for solving the wide range of different problems. But maybe nowadays the main area of using of C language is scientific computing. Well, and the next feature is that C is a comfortable language. On the one hand, it provides for good programming style. And on the other hand, it's rich enough to implement a program in creative way. Of course, maybe the program written in basic or written in Python may be more close to natural language, is more simple, but C program is also rather simple and can be understood by the programmers in a rather simple way. Well, we can take a look to the C language from another point of view, like language. So C language means programming language, and in our real life we use natural languages like English, Russian, French, German. So, but C language is rather close by its construction to natural language. First of all, it has its alphabet. Like natural language has the alphabet, and C language is also has its alphabet. And all the symbols of the alphabet is included in so-called ASCII table. And there usually we consider, I show you right now the symbols that included in C alphabet, but of course the main symbols are Roman letters, uppercase and lowercase. The uppercase and lowercase symbols are considered to be different. In other languages, like Pascal, it's not. In Pascal, the uppercase and lowercase symbol is considered to be the same symbol. There is no difference between uppercase and lowercase. Also, the digits are included in C alphabet, usual digit 0, 1, 2, 3, 4, 5, up to 9. In Russia, we called it Arabic digits. Maybe in your countries, these digits are called on some other way. And also the set of special and control symbols. And their special code, some special code called ASCII code is used for representation of additional symbols. For example, Cyrillic symbols for Russified computers. Well, let's take a brief look to the C alphabet. As I already told, C alphabet includes Roman uppercase letters from A to Z, lowercase letters from A to Z, digits from 0 to 9, special symbol underline, which are often used as a letter, and a lot of special symbols. Some symbols you know, you use it in other subjects like plus, minus, star, to denote addition, subtraction, multiplication, or division, less than, greater than, for comparison, and so on. But some symbols are special and is used only in C language. For example, vertical bar, ampersand. This symbol is used very often. Exclamation mark. Tweedle, and so on. Here we may see the complete list of these symbols. I pay your attention just on a few of them. Semicolon, parentheses, square brackets and figure brackets, double quotes, and a symbol empty space. The symbol that represents a space, it's also belong to the C alphabet. Well, of course, you don't need to remember all of these symbols, and of course you don't need to remember the codes that correspond to the symbols. But you should remember that in C language we can use only a predefined set of symbols. Only the predefined set of symbols that that are included in C language alphabet. Well, using this alphabet, we can construct words like in natural language. We use symbols to write words, and after that we use words to write sentences, and after that we use sentences to write the text. In programming languages, we use their alphabet to write lexemes, and after that, using these lexemes, we can write more complex constructions like statements, comments, and so on. And these constructions can be considered as sentences of programming language. And finally, using these sentences, we can write a program as a whole, like text. And so the program consists of special sentences that describe data, operation with data, and so on. And these cannot be written in arbitrary order. The program must be organized just in a fixed manner. First of all, the program is divided into several parts called subprograms or functions. One of them is called main function and implements all the algorithm as a whole using other slave or subordinate functions for performing subtasks, dealing with the data part and implementing a part of algorithm's processing operation. And these slave or subordinate functions are optional units of the program. And in the simplest case, the program may contain only one main function and preprocessor directives. So this is a general, very general program structure. First, we should write some preprocessor directive. Then we can write some functions. Functions are optional And in the simplest case, the program can contain only one main function. And this function begins the program execution. This is an example of the simple program. Oops, sorry. These two lines are preprocessor directives. It's better to write here. Include IO stream, of course. Include IO stream using namespace std. Then should be written header of the main function. After that, this figure bracket denotes the beginning of the function. This figure bracket denotes the end of the function, and the statements between these two brackets corresponds to the algorithm that are realized, that are implemented in the main function. We discuss about the statements, these statements later. Well, if you create a simple program using Microsoft Visual Studio, let me show you it's once again how to create a program when you start Visual Studio. You can press the button Create Project, select Console Application, and press the button Create. And Visual Studio creates you this simple program. This simple program contains preprocessor directive, and this simple program just outputs the message to the screen. Let's run it. And we see the hello world on the screen. Okay. Just I briefly say a few words about special symbols. There are a lot of special symbols that are used as lexemes of the language. Some symbols are very simple, and you know the meaning of this symbol, like plus, minus, star, slash, that denotes usual operations: addition, subtraction, multiplication, and division. But this sign is also used to denote some special operation, person sign. Symbol equals sign denotes the summing operation. These symbols define bit by bit operations. Symbols less than and greater than are used for comparison. Semicolon indicates the end of the statement. Figure brackets define the begin and end of the program blocks, and so on. Well, we consider these special symbols in details later. Here I just show you this as example. Well, some of the lexems or words of the language are intended for notation of some language statements, standard data types, directive names, and so on. Such words are called reserved words or keywords. And these words cannot be used for other goals. It can be used only in a predefined sense, in predefined meaning. Here we see just a brief list of these reserved words, like int, include, return, and so on. Well, we discuss about these words in details later. Right now, I just want to stress that when you type this word in Visual Studio, this word will be you see it with another color. Visual Studio automatically shows you reserved words like using, int, return, and so on. Well, one other important features in C program is related with their data types and identifier. Of course, in your program that you already write on practice, you will use some variables of some data types, like this, int a. What is the meaning of the word int?
Integer.
Yes, it's integer. So the variable a I can use as integer variable, but I cannot write here any identifier that I want. There are some rules about identifiers, and all of the information objects that we are going to use in the programs should be assigned with the identifier. And as the identifier, you may use a sequence of Roman letters, underline symbol, digits, and identifier should begin with a letter or underline sign. Theoretically, identifier can include any number of symbols, but only the first 32 signs are taken into account. But I think 32 signs for identifier is enough. Well, let's consider it in Visual Studio. Well, int a, and let me create two identifiers with the name a. It will be a mistake. Each identifier should be unique. And if you try to compile this program, compiler outputs you an error, int a redefinition. So you can define identifier only once. Then, but a lowercase and a uppercase will be considered as a different identifiers. Of course, you should avoid such declaration because a lowercase, a uppercase are very similar, and you should remember what is the difference between lowercase and uppercase a. Well, the next feature, identifier can contain numbers, can contain digits. So I can write here some digits, but the identifier should starts with the letter or underline symbol. So A1 is a good identifier, but 1A is not. One A is not a good identifier because it starts with a digit, but identifier can start with underline symbol. One A is a good identifier. Even underline 1 is also good identifier. Good from the point of view of compiler. It means that compiler can compile such a program and outputs you that it's okay, no mistakes. But from the point of view of programmer, of course, this identifier is not very good. And it's better to give the more long names for identifier. For example, let's consider the imagine, for example, that you should write a program that computes the maybe area of a circle. Area of a circle. Do you remember the formula for the area of a circle?
Pi r squared.
Yes, pi r squared. Well, in this case, well, I don't know. Did you consider on practice such type as a float for real numbers?
Yes.
Yes.
Formulas for areas and for circumference and stuff like that.
Okay. In this case, I can define identifier pi with value 3.1415, for example. Of course, it's not precise value. It's not a precise value of pi. And after that, I can define the identifier radius.
Maybe we can input by user reduce.
Sorry?
Maybe we can input radius by user like sin r, sin TNR.
Well, our goal is not to compute the precise value of pi, but I just show you some features of identifiers. Radius and float REA equals to pi times radius times radius. Okay. Let's output the result.
Don't you have to put like parentheses in the two radiuses?
Again, sorry, please repeat your question.
I said, don't you have to put parentheses for the radius so it doesn't?
Oh, no.
The order of operations? Okay.
No, it's okay. REA. In this case, the result will be the same if I put parentheses or not, because I use here multiplication.
Yeah.
Of course, the result will be the same. Let's run this simple program, and we see that the REA is 12.566. Well, it's not a goal to compute the precise value of REA. I just want to show you that in this case you can use here identifier A. Yeah? And this program still be correct. It means that this program also computes the area, the same value, but I use a not good identifier for pi, A. Of course, it's better to use here identifier pi. And the same situation for example, for radius. I can use here x. But if you look to this formula, pi times x, maybe you don't understand the meaning of this formula because you use not good identifier for a variable. You will have correct result, but the identifier is not very good. In this case, if you just take a look to this formula, you understand, oh, it's an area of a circle. Well, this words, it's right here on this slide is some recommendations about the choice of identifiers. Use the names from the problem statement. Well, if you write a program that computes the formula, the area of a circle, use identifier radius, pi, and so on. Try to give short identifiers. Because in this case, you can give the name like radius or REA of the circle. It's also a good identifier from the point of view of compiler, but it's rather long. It's rather long, and the program becomes long, and this program will be hard to read. in this case, it's better to give a short name, just area. Don't begin with underline symbol, because many identifiers in standard libraries use this mode of naming. And use underline symbol with the complex identifiers for better readability. For example, if you are going to compute another area, you can give the name area number 1 on such way. Okay, and the next thing that you can see in the program is comments. Comments is a part of the program, some special part of the program that is written just for explanation of your program, and this part is skipped by a compiler. And you can use a comment to describe your program on a better way. And there are two ways, there are two forms of comments. First comment begins with /* and ends with */. This comment can be placed in any part of the program. It can occupy one line, several lines, a part of one line, and so on. Usually these comments, this type of comments is used, for example, to write a long explanation or just to exclude some part of the code. For example, I want to exclude this code from my program. I just write here *//*, and this part will be excluded from compiler. Usually in Visual Studio these comments are colored with green, but it depends on the style, black or white style of Visual Studio. This is the first type of comment, and the second type of comment that is already used here in this simple program is so-called one-line comment or single line comment. You can write a // and the end of the string with this // becomes a comment. Well, in this program, these lines are single line comments. Also, for example, I can write here / and exclude this one line, or I can write a // at the end of the string to explain the meaning of this identifier. Usually these comments is written just before or after identifiers to explain these identifiers better. And the following recommendations about the comments can be given. Use at the beginning of the program a short comments describing the tasks to be solved, initial data, and results of computation. Write the comments in terms of problem and method of solving. Don't insert comments inside the statement, and don't write obvious comments. Of course, in your case, when you write first simple programs, you can write it without any comments. But for future studying, when you will write large programs that consist of hundreds of lines of code, it's better, of course, to write comments that explains your program on a better way. Well, and now we are going to talk about maybe one of the most important things that can be considered as a fundamentals of C language: data types. Data types. Of course, you already use data types in your simple program. You use int for integer numbers, float for real numbers, but we now discuss about these and other data types in details. In C language, every information element must be described as an object with concrete data type. Such information elements are constants, the information objects which do not change during the process of program execution, and variables, the data elements, values of which may be changed during program running. But to describe machine or computer data type, let's first discuss about some abstract data type. The notion of data type may be formalized by means of introducing the abstract data type. The abstract data type is a set of values and a group of operations carried out with these values. Well, the data type is described by the pair or tuple, set of values, and set of operations. Let's consider two simple examples of different data types. I write these examples in the program. I will use it like board. Usually, of course, I write these examples on the board, but we have now online lessons. Well, let's consider such numbers as natural numbers. Do you remember what numbers are called natural numbers?
Yeah, numbers like 1, 2, 3.
Yeah.
Yes, 1, 2, 3, 4, 5, and so on. Well, let's consider the set of values 1, 2, 3, 4, 5, and so on, natural numbers. And to define this data type, natural number, we can define special operations. The operations, I cannot use here this sign, sigma. Addition and multiplication. Because if we consider subtraction, subtraction can give us negative result. The result that doesn't belong to the set of values. Yes, to natural numbers. And of course division, we cannot include division. Well, this is an example of one data type. Set of values and the group of operations. Let's extend the set of values. Let's consider integer numbers. All of the integer numbers. In this case, the set of values starts from -infinity and so on, for example, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on up to infinity. In this case, I can include here subtraction. Yeah. If I include here subtraction, these two sets, set of values and set of operations, described integer data type. Let's extend the data type more. Let's include here division. In this case, we will have all of the numbers from -infinity up to +infinity. By the way, do you know how such numbers are called in mathematics?
Real numbers?
Not correct. Real number. It's not exact. It's not precise answer. Not real number. What numbers?
What the question, sorry?
If I include here in the set of operations division, what numbers I get in this case, and how these numbers are called in mathematics?
Rational numbers?
Rational number.
Right. Rational numbers. So here we have integer numbers, and in this case, rational numbers. This name comes from mathematics, but in programming, of course, sometimes we called it rational and real and rational. But if I include here one more operation, like square root, for example, square root, I extend the set of numbers. What? Irrational. Yes.
Irrational.
Yes. Irrational or Sometimes it's called algebraic numbers, and so on, and so on. Well, again, now it's not a goal of our lesson. I just want to show you that the data type is defined by two sets: set of values and set of operations. And these two sets are very closely related. We cannot consider set of values without set of operations. Data type becomes data type when we consider this pair, set of values and set of operations. But this is abstract data type, mathematical data type. But if we consider computer data type, we should store on some way the values from the set of values, and we should implement on some way the operations from the set of operations in computer. So we should suggest some algorithm how to implement the operations, how to store the numbers in computer. As a result, we can introduce so-called machine data type as a tuple with three elements: set of values, set of operations, and storage structure, storing structure. The method of representation and processing data from this set of values using this set of operations. Of course, in computer, we cannot store infinitely many numbers. And when we discuss about abstract data type, the abstract data type starts from minus infinity up to plus infinity. In computer or machine data type, these types has some final number. The largest integer number. I don't remember exactly how it's written. Is there
it's n underscore or underline max.
In int max, yeah.
Yeah.
In int max, yes, okay. I remember that max int or int max, something like this. Max, the largest integer number, and for we have the same, the largest positive and the smallest negative number, and so on. So any machine data type has their range between the smallest and the largest number. Well, in C language, there exists so-called basic or system or predefined data types and so-called derived data types, the types constructed by programmer. Basic data types are already implemented inside the language. So in the language, the value, the set of values and set of operations are already defined and already implemented. And when we will talk about derived data types, set of values and set of operations should be defined manually by programming. When we will talk about the numeric data type, operations are usual. Use addition, subtraction, multiplication, and division. Okay. On this diagram, you may see the classification of data types in C language. The basic data types and derived data types, and also the basic data types are divided into special void type and scalar types. And scalar types are divided into integer valued data types and real valued data types. And also derived types are divided into scalar types and structured types. We start our consideration from the integer valued data types, and after that we discuss about real symbolic types, and later we will consider derived types. Well, the notion of data type is related with the notion of variable. Variable is an information object, value of which may be changed in the course of program execution. Every variable has the following attributes: name, type, class of memory, and value. When you declare this, when I declare this value, this variable, I define the data type, int, the name, and I don't assign any value. For this variable, I define data type, float, name by, and I assign a value. Well, the name of the variable must be unique identifier, which doesn't coincide with keywords. I cannot use, again, I repeat that I cannot use a keyword to create identifier. For example, I cannot create a variable with the name int, because int is a keyword. But if you want, if you have such strange desire, you can create an identifier underline int or int1. These will be the good identifiers, because int and int1 are different words. Variable type indicates a data type, the value set of which defines the possible values of the variable and operations that may be applied to this variable. Well, in these simple programs, we use usually int and float that corresponds to integer and real numbers. Class of memory defines the lifetime and scope of the variable. We will discuss about it later. The variable value is a concrete constant of the type value set, which specifies the variable state as a fixed time, a fixed moment of time. Name and type of the variable are constant attributes, and they cannot be changed. And the value can be changed in the course of program execution by assignment or input operations. This is a general form of variable declaration. The values in brackets are optional and may be omitted. Type of the variable, name of the variable, initial value is optional parameter, and class of memory is optional parameter too. About classes of memory, we will talk later, maybe in the second semester next year. This is an example of declaration of a variable with a static class of memory. And the same situation for constants. It's very similar to variables. Even you should write a keyword const before the type. In this case, the value of the constant should be obligatory. You should write the value. And the value cannot be changed in the course of program execution. Okay, let's consider some examples. Int A, it's good, but const int A is wrong because I didn't assign the value to this constant. After that, I cannot change the value of this variable. I can't assign a new value to this information object because it's constant. But if I remove const, the program will be correct. And also it will be correct in this case, but let's consider some very important feature. Let me write here output statement. Let's output the value of variable to the screen. What we see on the screen now, it's very simple. We see 11. We will see A equals to 11. But suppose that I remove this line. What we see on the screen now?
A.
Nothing.
A?
Since it's not defined, I don't know. I think it would show just A.
Nothing.
Well, you say the correct words. The value of A is not defined, is undefined. I don't assign any value to the variable A.
There's error.
Yes.
Error.
Oh, okay.
Okay, it's error. It's output. Well,
You should
but,
declare variable.
In previous versions of Visual Studio, such program can be executed, and we see some random number on the screen because A is not defined, but Visual Studio 19 checks this mistake. Or okay, so it's very good. So if you forget to assign a value to variable A, Visual Studio outputs you this mistake that you cannot use the variable A without initial value. Maybe I can give you such example.
I have a question.
Wait a minute. Yes. So in this case, of course, I explain you this example later, but in this case, we see the undefined value. So value of A is undefined, and we see on the screen some strange number. This program is little bit complex in comparison with this simple program, and compiler can't understand that this value is not defined. But in this, for this simple case, yes, this mistake can be checked by compiler. Okay, you have a question. You're welcome.
I have a question. What is the difference between initial and declare variable?
Again, please repeat. What the difference
between declare variable and initial variable?
Between declaration and initialization?
Yes.
Okay. Again, I repeat. Here, this line, I declare the variable, but I don't assign a value. This value is without, this variable is without value. And if I write here int a equals to 10, I initialize this value. I declare and initialize, and it's an initialization of the value. This is just a declaration, and this is initialization, assignment of the initial value. And the best way is to assign initial value for variable in any case. In this case, the program is correct, and we see 0 on the screen. Well, other questions, please?
Thank you.
Okay, and the last slide for, oh, not the last, we have two more slides. And if we need to declare several variables or several constants with the same attributes like memory class and type, we can write it. We can write it here like this. Constant, type of the constant, name of the constant, and after that the second name, third name, and so on. And the same is true for variables. If we need to declare several variables, I can write it here using comma. Int a equals 0, b equals to 1, c equals to 3, and for example const int d equals 2, f equals 5. I can declare a set of variables or set of constants in one declarative statement. And in this case, I can use initialization or I can skip it. It will be correct. In this case, A and B, the variables A and B will be undefined, not initialized, and C will have initial value 3. If I assign something, I have only B without initial value. But the good style is supposed to assign initial value for any variable. Okay, and the last slide. And when we discuss about the constants, we can say that there are two types of constants in the program. First type is called named constants, constants with name. Like this one, D, F. So after its declaration, I can use D and F as a constants with values 2 and 5. And the second type of constants are so-called literal constants or unnamed constants. Literal constants have no names and appear in statements immediately. So any number that you use in your program can be considered as literal or unnamed constant. From this point of view, these values 1, 0, 3 are literal constants. If I write some output statements, for example, 2 plus 2, for example, I forget how to compute 2 plus 2. I want to compute it using this program. In this case, these two and these two are literal or unnamed constants. Also, I can use here named constants, D plus F. I can use named constants, or even named and unnamed constant. Well, this is the last slide of this presentation. Do you have any questions?
No.
About the lesson? Well, we discuss in details about data types, and on the next lesson we will continue, and we discuss about the range of representation of integer numbers, the range of representation of real numbers, the storing structure for integer and for real numbers. And after that, maybe lesson after lesson, we start to consider the main algorithmic structures of C language, like selective structure, if, switch, loop structure, and so on.
Sir, I have a question.
Yeah.
I was just wondering, you said that the C program can't compute infinite numbers, but what if you use like the greater than sign? Like everything greater than 1, you could have infinitely many results.
Yes. Well, I said that in mathematics, when we, for example, consider integer number in mathematics, the integer number can be infinitely large number, but we cannot represent in computer this very, very large number.
Okay.
It always, for any data type, we have a range of representation. We have the largest number, and this is the last number that can be represented. This number plus 1, it cannot be represented in computer.
Okay.
Of course, this is true for built-in data types. For some special data types, of course, these restrictions is not so strong. We will discuss about it on the next lesson, about the range of integer, about the range of float numbers.
Okay,
Can you send us this presentation?
Sure.
Right.
After the lesson, I will send you this presentation and the link to the video of our lesson.
Okay, thanks.
Well, our time is over. If you don't have any questions, I stop recording.